Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Harif Farhan and I will be explain about question 1 by using manual calculation. So firstly, for question 1A, we need to design the circuit to obtain an overdamp, critically damped and underdamped response. So firstly, we need to find the value of C because the C is unknown. We use the formula of omega equals to 1 over square root LC. So L is the inductance and C is the capacitance value. So we insert the value of the omega, which is we discussed is 100 radian per second, and then we insert the value of the inductance, which is 0.5 Henry. And after we do the algebra, then we finally found the answer, which is 0.2 millifarad for the value of the capacitance. Then after we find the value of the capacitance, we need to find the value of each resistance according to the overdamped, critically damped and underdamped response. By using the formula of R equals to 2 tau times by square root L over C, then we finally found the answer for the underdamped, which is R value for the overdamped response, which is 160 ohm. For the critically damped is 100 ohm. And finally, the answer for the underdamped response for the resistor that will be used is 70 ohm. Then we need to find the expression of VC and IL for T more than or equal to 0 for each of circuit design, which is overdamped, critically damped and underdamped. So firstly, we're gonna do the overdamped first. We take the information that we calculate before, which is the value of the R and capacitance, the inductance. Then we need to find the alpha first. So the alpha, we use the formula of the R over 2L. Then the value of the alpha is 160 radian per second. Then to find the IL, we must use the expression which is given by ILT equals to A1 exponent S1T plus A2 exponent power of S2T. Then after we find the value for the A, then the value of the IL is 0.32 times by exponent. So the value of the S1 is negative 35.1. So in the bracket, which is, as you can see, the S1 value is negative 35.1 minus by exponent power of negative 284.9. So that is the value of the IL. Then we need to find the value of the VC for the overdamped response. We use the formula, which is 1 over C times by integration of IT dt. Then we insert the value into the expression. Then we finally find the answer, which is VC equals to negative 45.6 exponent power of negative 35.1 plus 5.6 times exponent power of negative 284.9 volt. So that is the answer for VCT for overdamped response. And next we need to find the critically damped for the IL. The answer for the IL after we calculate, which is IL equals to 80 T times by exponent negative 100 T M. So that is the final answer for the IL for the critically damped. For the answer of critically damped, which is VCT, we for the calculation, as you can see, we need to integrate first. As you can see that I've already marked the rectangle one. We need to integrate by part. After we integrate by part first, then we finally found the answer, which is VCT equals to 400k times by negative t times exponent power of negative 100t over 100 plus exponent power of negative 100t over 100 volt. So that is the final answer for the VCT for critically damped. And lastly, for the under damped, we need to find the alpha first. So the alpha value is 70 radian per second. For the S1 and S2, we need to switch the calculator from degree into radian after we calculate by using calculator. The answer for S1, because we need to find the S1 and S2 first, the S1 value is negative 70 plus J71. For the S2 is negative 70 minus J71. We need to use the formula, which is exponent negative power of negative 100t times by A cos 71t plus B sin 71t. So after we calculate, we need to find the A and B first. Then after we put the value of t is 0, we got A equals to 0. Then we need to find the value of B. And after we insert the value of A into the expression, we finally find the value of the B, which is 1.1. And after we find the value of A and B, we can finally insert the value of the A and B into the expression. Then we finally got the answer of the IL t equals to 1.1 exponent power of negative 100t sin 71t m. So that is the answer for the under damped response for the current. And lastly, we need to find the VC. So same goes to the procedure that we did on the overdamped and critically damped. We use the formula of 1 over C times by the integration of IT dt. So the value of the VCT is exponent power of negative 100t times by negative 0.6 sin 71t minus 0.4 cos 71t. So that is the final answer for the VCT of the under damped response. So that's all from me, and we're gonna proceed to the simulation. Will be presented by my friend. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Fikri Akmal bin Abdul Razak, bernombor matriks DE230101. Sekarang saya akan membentang part tugasan saya, iaitu question nombor 2. Okay, question nombor 2 ni soalan dia adalah find the voltage V1, V2 and V3, tapi menggunakan dua circuit analysis, iaitu nodal dan mesh analysis. Okey, pertama sekali saya gunakan calculation nodal analysis. Seperti kita tahu lah, V1 sama dengan 30 degree voltage, sama dengan I4 sama dengan 40 degree. Okey, node 1 bersama dengan tu, node 1 bersama V1 tu bersamaan dengan V0 60 degree, dan node 2 adalah bersama dengan I3 tambah I6 sama dengan I7. Dari situ saya rungkaikan I3 ni bersama dengan V1 tolak V2 per J10, dan I6 V3 tolak V2 per J10. Apabila kita tambah dua tu, kita akan dapat nilai dia. Tapi sebelum tu kita kena masukkan nilainya. Lepas saya masukkan nilainya, saya dapatkan nilai yang terakhir adalah 120 negatif 60 degree. Lepas tu untuk node ketiga, saya rungkaikanlah I2 sama dengan I4 sama dengan I8 tambah I6. Jadi macam biasa rungkaikan, masuk gantikan I2, I4, I8, I6 tu dengan voltage per arrow, masukkan nilai dia, dan akhir sekali kita akan mendapatkan nilainya adalah J4 V J4 tambah J11. Okey. Dari situ kita akan buat kaedah metrik tu. Kita masukkan nilai dia. Kita dapat yang pertama adalah negatif 3. Bukan yang pertama, yang awal punya adalah negatif 3. Dan yang pertama adalah 144.3.15 tolak J179.62. Dan yang kedua adalah negatif 565.63 tambah J179.81. Okey, untuk mendapatkan V2 kita menggunakan yang pertama bagi yang awalnya adalah 48, dan nilainya adalah 48.76, angle 172.910 volt. Yang untuk voltage 3, angle 2, yang kedua bagi yang awal sekali 197, dan nilai yang terdapat adalah 197.86 dan angle negatif 17.63. Okey, jadi akhirnya dapat semua nilai V1. Dan seterusnya saya menggunakan teknik mesh analysis. Untuk mesh analysis ni kita masukkan nilai negatif 60, angle 30 tambah J10 darabkan I1 tolak I3. Dan nilai-nilainya dapat, yang pertama adalah 60 angle 30, sama juga macam mesh pertama. Mesh 2 nilai yang kita dapat adalah J16. Dan yang ketiga adalah nilai negatif J10 I1 tolak J10 I2 tambah 8 J20 I3 sama dengan kosong. Seterusnya saya guna Cramer rule. Masukkan nilai-nilai tadi macam sebentuk metrik 3.3, dan masukkan, dan pertama sekali, awal sekali kita akan dapat nilai 32 tambah J80. Yang pertama adalah yang kita dapat adalah 3149.69 tambah J2311.38. Dan yang kedua adalah saya dapat nilai negatif 847.23 tolak J578.2.77. Dan yang ketiga saya dapat nilai 1039.23 tambah J280. Dan sekali saya nak dapatkan nilai current dia atau I1, I2 dengan I3. Jadi pada yang pertama bagi yang awal adalah 45.34 hingga negatif 31.93 ampere. Yang kedua adalah 67.83 hingga negatif 166.52. Dan yang ketiga 12.49 hingga negatif 83.12 degree. Sekian daripada saya, terima kasih.
Hi, my name is Muhammad Hakim. My metric number is DE230050, and today I will continue with the simulation. As we can see in the question 1, I will start with the question 1. We have to pick our omega value, and the omega value that we choose is 100, and then we can calculate the total R for over them, which is 320, critically damped, which is 200, and lastly under damped, which is 140 ohm. And I will show you the simulation. Okay, this is the circuit that I have done using multisim, and this is all the component that we needed, and we just need to change the value of R. As you can see, the first one is 320 ohm, which is we are looking for the overdamp graph. And if you run this circuit, we can get, this is the overdamp graph. Then we continue with critically damped. We need 200 ohm, like in our calculation, 200 ohm for critically damped. We just put it into our simulation, and then we click run, and this is the graph for critically damped. The red line is IL, and the green line, which is the volt. And then we go to the last one for under them. We need 140 ohm. Is it correct, like our calculation? 140 ohm. Then we just click run. So this is for under them graph, and then we need to merge all three of them. We need graph 1 and then graph 2. Alright, so this is all three of the graph that we get, which is the first one, the green one is over them, the blue one is critically damp, and the light blue one is under them. So we need to check, analyze, give you the shorter time reaching at 80%. So I have done the line. So this is the picture for 80%. As we can see, over them go first, and then it hit the critically damp, and lastly is the under damp. Okay, that's all for question 1. Okay, now we continue the simulation for question 2. As we can see, this is the circuit that we need to create. For the value of the inductor and capacitance, for the inductance, we get the imaginary number J10. We need to convert it into ohm, real number. So we use the formula J omega L equals to J2 pi FL. And for the capacitance, we need to change the imaginary number to the real number using formula negative J over omega C equals to negative J over 2 pi FC. And then we can get the value for the inductor 0.1 Henry and the capacitance 2.5 millifarad. And this is the circuit that I have done using multisim, and we can put all the component that we needed, and we put the things that we need to measure. Okay, if I click run, we can get the result. We just put pause, and we can take all the result. The result in this simulation and the calculation may be a little bit different. Yeah, that's all.